In the blink of an eye, in just 19 seconds, a new journey is born, taking us deep within the human brain and the molecular mechanics of addiction. How can a substance so small lead to an experience so profound? What unfolds in those precious seconds of decision leads to a lifelong intrigue with danger and euphoria. In this exploration, we uncover the molecular physics at play in crack cocaine, a substance that has irrevocably altered lives. Crack cocaine is not just a drug, it is a potent cocktail of chemicals that hijacks the brain's reward system. When inhaled, crack travels into the bloodstream, reaching the brain within seconds. Imagine the rush, a euphoric wave flooding your body. What is happening in those moments? The answer lies in the molecular dance of dopamine. Dopamine, a neurotransmitter responsible for pleasure and reward, surges in the brain as crack cocaine binds to dopamine transporters. This process prevents the reabsorption of dopamine, flooding the synapses with this powerful chemical messenger. What begins as a 19-second high transforms into an addiction that can last a lifetime. Historically, crack cocaine emerged in the 1980s, characterized by its crystallized form and lower production costs. Urban communities were struck hardest as the availability of this drug spiraled. Anecdotal evidence transformed into a public health crisis that spurred debates on moral versus medical views of addiction. As the drug spread, so did its effects. Communities fractured, families shattered, and lives were forever altered. Yet what goes unnoticed in this narrative is the brain itself, trapped in a web of molecular reactions. The journey of crack cocaine isn't merely about consumption, it's about the brain's adaptation to the presence of the drug. Repeated use leads to desensitization, requiring more substantial doses to achieve that initial high. Brain scans reveal significant changes to the neural pathways, highlighting how addiction uproots the brain's architecture. Research shows that the more frequently cocaine is used, the more difficult it becomes to feel pleasure from everyday activities, ushering in a chaotic new reality. Scientific studies provide insight into the brain's reward circuit, revealing how chronic exposure to crack alters genes responsible for regulating dopamine. These genetic changes compound the problem, perpetuating a cycle of craving and use. The molecular physics of addiction does not merely concern the brain, it reverberates throughout society, shaping and reshaping lives. One striking element of crack's impact is its timing. The pivotal 19 seconds when the high floods the brain creates a window of vulnerability. During this flash of intense pleasure, cognitive functions rapidly diminish, clouding judgment and reinforcing compulsive behavior. As soon as those moments fade, the battle within the brain intensifies, igniting the hunger for more. The narrative surrounding crack cocaine has shifted in recent years. From criminalization to a focus on rehabilitation, society is now grappling with the understanding of addiction as a complex disease rather than a moral failing. Advances in neuroscience continue to inform policy and treatment, leading to new approaches that acknowledge the deep-seated molecular issues at play. The journey of understanding crack cocaine is not just one of substances and society, it is a call to action. By deciphering the 19-second hijack that leads to addiction, we unveil the need for empathy and comprehensive support systems. Each high is a fleeting moment, yet the repercussions linger. In recognizing the science behind addiction, we can forge pathways toward healing and hope. As we conclude our exploration, let us remember that knowledge is power. Understanding the molecular physics of crack cocaine not only enhances our comprehension, but also fosters compassion for those caught in its grip. The road to recovery can seem as elusive as the high itself, but armed with insight and a commitment to change, we can navigate this landscape together. Join us soon for another documentary.